Hello everyone, welcome back again to Playwright with TypeScript End-to-End Automation Testing Training Session 5. Today we'll cover couple of very important key features from the TypeScript where you will learn TypeScript OOPS concept. OOPS is nothing but the object-oriented programming structure. In the OOPS we'll learn about the inheritance, polymorphism, abstraction, encapsulation, and in the inheritance we'll learn about different variety of the inheritance along with the importance of super keyword. In the polymorphism we'll learn about the compile time and runtime polymorphism. In the abstractions you will learn about the abstract class, method and interface. And in the encapsulations you will learn about how we can encapsulate data using the getter and setter, and what are the different access modifier available through which we can encapsulate data also. Then we will discuss about the TypeScript read-only properties. Then at last we will try to cover the TypeScript error handling, how we can handle the error with the help of the try, catch and finally block. So let's start with the OOPS concept. So OOPS is nothing but the object-oriented programming structure. All the modern programming language starting with C++, Java, Python, C Sharp, JavaScript, TypeScript mostly support the OOPS concept. So OOPS is nothing but the object-oriented programming structure. It's a popular programming paradigm which nowadays been widely adopted in the software development industry. OOP is based on the concept of object, which are nothing but the instances of the classes that encapsulate data. Data is nothing but the variable and behavior, but which is nothing but the method. TypeScript is a statically typed superset of JavaScript is designed to support the development of large-scale applications and is also an object-oriented programming language. So whenever we are talking about the JavaScript type TypeScript, so JavaScript does not fully support OOPS, whereas TypeScript is fully supporting the OOPS. So that is the reason TypeScript is very popular in the market. So TypeScript fully support OOPS or object-oriented programming concept, including the four key pillars, which are nothing but inheritance, polymorphism, abstraction, and encapsulation. OOPS provides features like classes, interface, and access modifier to help structure code in a modular, reusable, and maintainable way. So four key pillar we talked about that, like inheritance, polymorphism, encapsulation, abstraction. Apart from these four key pillar, the three important key part of the OOPS is but like class, object, and constructor. So class and object we already learned, I think last day, and a constructor also have covered in one day. But class is nothing but is a blueprint for creating object. It defines properties, data, and method or functions that are common to all instances of the classes. So class is physically not exist but logically exist only, whereas object is nothing but instance of the class that has its own set of properties and method. So unlike class, object physically and logically exist in the real world. Constructor is nothing but a special method within a class that is automatically called when new object is created. It's primarily used to initialize the object properties. Then we'll talk about the four key pillars of the OOPS: inheritance, polymorphism, encapsulation, and abstraction. So inheritance is nothing but the parent-child relationship. So say we just giving a real-time example. So like definitely we'll be having some parent, mother and father. Similarly, my father also having some parent, right, grandfather. So my father is having the properties from the grandfather. Similarly, I am also trying to acquire the property from my grandfather or father. So that is the way. It is nothing but the parent-child mechanism where child is trying to acquire all the property from the parent class whenever inheritance is like mechanism already established. So inheritance allows a new class to derive from an existing one, reducing or modifying behavior and prompting a hierarchy among classes using the extend keyword. So whenever we are dealing with the class to class, you will need to use the extend keyword. The super keyword is used in the subclass constructor to access the superclass constructor and method. I will discuss in detail in the next slide what is inheritance. And polymorphism is nothing but the poly means many and morphism means form. It derived from the Greek word. So it is many form. So primarily there are two type of polymorphism called method like called compile time polymorphism and called runtime polymorphism. So polymorphism enables object of different classes to be treated as object of a common superclass, allowing a single method name to perform different actions depending on the object type. The encapsulation is nothing but the data hiding. So I do not want to completely showcase my data to all the user, because I want to hide it, because in case I want to access everybody, it is like kind of theft issue for me, right? In case you are having some bank account, right, nobody can access your bank account or can get to know how many balance is there. Instead of that, in case you are depositing or withdrawing the money, you can, right, get the message in your mail or mobile. That is the way you can get to know. Or whenever you are using your internet banking password, you can also get to know. So this is encapsulation called data hiding. So encapsulation can be achieved via access modifier. There are three primary access modifier available: public, private, protected. We'll discuss in the upcoming slides. So these principles or encapsulation principle bundle data and the method that operate on it with a single unit or a class. It controls visibility and protecting the internal state. The getter and setter methods are there to provide control access to private properties, allowing for validation or logic, data retrieval or modification. So there are encapsulation how it handles through the different three access modifier: public, private, protected. Apart from that, we can also define private variable. Then we can have the getter and setter method. This is the way you can handle the encapsulation. Then a last one is called abstraction. It is encapsulation hiding the data, whereas abstraction means hiding the implementation details. Right? Whatever method we are creating, we want to hide it. Right? So that is the way it hides complex implementations details and show only the necessary features, often implemented using abstract classes and interface. Abstract classes serve as the blueprint and cannot be instantiated by their own. They can contain both implemented and abstract method that must be implemented by derived classes. Interface define a contract for the shape of an object or a class, specifying the properties and method that must be present without providing the implementation details. So what is abstraction? Simple example. Say we are sending a mail and somebody is receiving a mail, but nobody know what is the logic is happening. In case we are sending a message through our mobile, right, it can be Android phone or iPhone, but nobody know how it is happening, right? We are able to send and receive. So that is the way implementation logic or internal logic, we are hiding it, but we are able to get the desired result or outcome. So abstraction can be done through abstract classes concept or interfaces concept. We'll explain in the upcoming slides. So let's start with the inheritance. So I already told that inheritance is nothing but the parent-child relationship. So in TypeScript, inheritance is one of the core object-oriented programming concept which allow a new class, which is nothing but called child class or derived class, okay, or subclass, to reuse the properties and method of an existing class. It is called base class, parent class, right, or the super class. Okay, so wherever we are trying to inherit, it is called child class, derived class or subclass, and whatever class we are trying to inherit from, where it is called parent class, base class or the super class. So this inheritance promotes code reusability and helps to organize code into logical hierarchies. So JavaScript, what is the main difference between JavaScript and TypeScript in context of OOPS? So JavaScript uses prototypal inheritance, but not classical inheritance like Java, C++, other programming language like use. So TypeScript uses class-based inheritance, which is simply the syntactic sugar of prototypal inheritance. TypeScript support primarily three level of inheritance: single level, multi-level, and hierarchical inheritance. In TypeScript, a class inherits another class using the extend keyword. So there are five inheritance concepts available in the real world: single level, multi-level, hierarchicals, multiple inheritance, and hybrid. So what is single inheritance? It is nothing but one class, one parent, right? One parent, one child. Whereas multi-level means a chain of inheritance, like grandparent to child. So child is able to acquire the properties from the parent and grandparent. Whereas single level, only one parent, so child will be able to acquire the properties from the parent. Hierarchical means one parent can have multiple childs. So in our life, right, we are having a single parent, right? But from multiple siblings might be there. So this is called the hierarchical. And multiple inheritance is not possible through the class concept in TypeScript, but it is possible through the interface concept we will learn later. What is multiple inheritance? Means one kind of child will be having the multiple parents. So anyway, in our life we'll be having two parents, mother and father. But in TypeScript world, multiple parent is not possible, right? It will be only one from a single parent class. So TypeScript does not support multiple class inheritance directly. A class can only extend a single parent class. The design choice, consistent with language like Java and C has, helps avoid the complexity of the diamond problem. That is the main concern. Because of the diamond problem, right, we cannot use that multiple inheritance in the TypeScript with the class concept, but same is possible through the interface concept. So TypeScript provides workaround and alternative pattern to achieve similar functionality, primarily through multiple interface implementation. A class can implement multiple interface which allows it to adhere to multiple contact or structure. This enforces that the class provide the properties and method defined in all implemented interface. Whenever I'll be giving the real-time example, you will be able to get the clear understanding. What is hybrid inheritance means? It's nothing but at the same time above four inheritance we are able to any or more than two inheritance we are trying to implement it. But TypeScript does not directly support hybrid inheritance using the classes. Hybrid inheritance is nothing but a combination of two or more type of inheritance, which is typically involve multiple inheritance, a feature not available for classes in the TypeScript. Now let's discuss about the single inheritance concept. Okay, so today what we will do, single inheritance is nothing but single parent and one child. So let's create a file here today called day5.ts. Okay, so just I will narrow it so that we can get the better visibility of the VS Code editor. So let's try to create a class. What is the syntax we need to use? We can use class syntax. Let's try to create a class called animal. Okay, so this is the syntax for the class, a block of code, class name and animal. Now we can have some method. Okay, so I can use some method called drink. So this is the way you can have it, and return type is void. So I'll be defining it void. Now we can have a block of code. So what we can do, we can use console dot log, and here I can try to print that uh, mostly animal drinks water, because every animal is mostly drink water, right? Now what I'll do, I will try to create one more class. Okay, this is the animal class. This should be parent here. And from the animal class, what we can do, we can try to create a child class. You could see the same class is not able. We cannot create it, duplicate class. So let's try to create a class called dog. Okay, and where we can try to create a method called eat. Okay, what we can do? Okay, dogs eat anything, like dog eat meat, fish, rice, all this stuff. So dog used to eat meat. Okay, so this is the way I have created a class. Now let's try to create a object for this dog class. Okay, dog, say object dog. I can make it object o lowercase equal to new dog. So that is the way you can create the object, for instance. Okay, here we need to give it late variable. Okay, now what we can do, we can try to using this object, let's try to access both the method dot eat. You could see it is coming where we already defined at the class level. But is it possible to access this drink method? So two class is already there, right? We logically understand that animal is the parent class and dog is the child class. But is it possible to call it, right? In case you are running the code here, it should be fine, perfectly fine, right? So let's run it. So you can change that file name here, day4 and let's run it. So you could see, day 5, it will be day 5. Okay, so you could see dog used to eat meat. That is perfectly fine because I am creating the object for the dog class directly where it method is there. But is it possible to access the other method whatever created in the animal class? What method created? Drink. So let's try to change it to drink here. Let's see what's happening here. Okay, you could see immediately error is coming. Property drink does not exist on the type dog. Okay, so that is the problem. So though we are defining, we are able to logically understand this is the parent class, this is the child class, but still TypeScript not able to understand. Why? Because we have created those two separate class, but we did not uh, build any relationship. So how we can make the dog as a child and animal as a parent? So we need to, in the go to the child class, we need to use the extend keyword and need to call the parent class. Okay, that's all. Now your dog is called your child class or subclass, and animal is called parent class or the base class. Now you could see that as and when I'm implementing that inheritance concept as a parent child relationship, automatically this method, my child class object, can use it. Now you could see there is no error message. Now if you run the code, it will be properly work. Okay, you could see mostly animal used to dog drink water, and this is also coming. So this is the concept of single level inheritance, one parent one child, and how we can make the child and parent relationship established with the help of the extend keyword. The class, the child class extend the parent class. So this is the way we can go with the single level inheritance. Now let's try to understand about the okay multi level inheritance. Okay, so let's copy this code here. Okay, let's create an animal class here. That is fine. Okay, let's create a dog class. That is fine. Now let's create another one more class, multi level. Okay, that means one grandparent, one parent, one child. Okay, here I can try to create a class, another class called say sleep, because dog used to sleep, which is extending the dog class instead of animal. Okay, here I can have method called sleep method. Dog used to sleep in during night time. Okay, now what is happening? So sleep is a child class, dog is a parent class. And for dog, you could see dog is a parent class, sorry, dog is a child class or animal is a parent class. That means sheep is a child class, dog is the parent, and animal is the grandparent here. So this is called multi-level inheritance. Now what we can do, I can try to directly create the object for the child class, which will access all the properties from the parent and grandparent both. So let okay obj sleep equal to new sleep. This is the way I can create the object. Now what I can do, I can try to call it all the method from the child class. Sleep method is fine perfectly. Then parent class, call it, it is fine. Then grandparent class also dot drink. So that is the way you can have the relationship called parent and child and grandparent. You could see dog is used to sleep during night time, dog used to eat meat, and mostly animal used to drink water. So this is the way we can have it. Okay, this is called multi level inheritance, grandparent, parent, and child. Now let's comment out the code and let's understand one kind of more inheritance concept called hierarchical. What is hierarchical? one single parent having the multiple children. So that is the concept of the hierarchical, right? Okay, so let's hierarchical is nothing, one parent class, multiple child class. So what I can do, I'll be creating a parent class called animal, and where I can define ring. Okay, then I can have dog class and extending animal. Now I'll be having one more class called instead of dog, I can have one class called tiger. Okay, or say goat class or animal. So it's extending again animal. That is the reason animal is the parent class and this is two child class dog and eat because both are extending animal. So here we can have again same method called eat. So what we can do? Okay, here I can mention goat used to eat grass like that. Okay. Now we can try to create a object called object dog. Okay, called dog. Okay, and with the help of the object dog, what we can do, we can call that eat and drink because the eat is nothing from the coming from the parent class, child dog class only, and drink is coming from the parent class with the animal. So animal is the parent for both of them, and both are the child. Dog and goat are child. Now similarly, we can try to have one more class for the goat. Sorry, let obj goat and new goat, and then with the help of this object I can call that parent class and the goat class method also. Now let's run it. You could see dog used to eat meat and mostly animal drinks water. This is the common from the dog. And now for the goat, okay, goat used to eat grass and mostly animal which is coming from the parent class. So that is the way, like one parent will be having two child class and both the child can access the parent properties commonly. So this is called hierarchical inheritance. Like, so it is nothing but one parent class multiple child class, and multiple inheritance is not possible through the class concept but will implement through the interface concept. I will, whenever I will covering the interface, that time you can get to know how multiple inheritance also possible in the TypeScript through the interfaces instead of the class, which does not allow, and hybrid inheritance is not supported in the TypeScript at all. So this is the concept of the inheritance. Now we'll discuss about that importance of super keyword in TypeScript. So during inheritance, mostly we use the super keyword. So TypeScript uses the super keyword to call the properties and method of the parent class directly. The primary use of the super keyword is to call the constructor of a parent class or to call the method from the parent class. So let's try to see the implementation here. Okay. So let's copy this part code. So you'll be having animal class and you'll be having dog class. Okay. So here what we can do, we can have this method is fine, or otherwise we can try to define a variable, okay, called name. This is the variable I'm defining. Okay. Then what I'm doing, creating a constructor. Okay. Here I'm passing name string and I'm giving the body of the constructor. So we need to use this dot name equal to name. Okay, so this dot name is nothing this, and this name I'm passing is matching here, and we can print something console dot log console dot log called the name of the animal is, and I can concatenate with this particular variable called name. That's all. I can create the constructor. Now what we can do, now dog is extending animal class. So again here we can try to copy it, and same way we are trying to define it. Okay, let's define one more variable called breed, right? Every dog will be having their breed. Okay, same string, and we are creating a constructor here. Constructor same way. Okay, name string, and apart from that, we'll provide that breed, which is also passing. Okay, so name anyway will be accessing it, and breed also we are passing it here. Okay, so then what we are doing? Okay, this dot breed equal to breed. Error message gone. Now here we need to call this parent class constructor here, because we are passing two variable, but one variable we are passing it here, right, in the child class. So how can I call this name? So what we can do, we can try to call, use the super keyword. Super keyword, where with using the super keyword we can try to call the constructor of the parent class, or we can try to call the method of the parent class directly. Okay, super, and we can provide the name variable. That's all error message gone. Clearly see. Now here we can print out the breed of the dog is. Dog is this variable, breed variable. So it is calling the name also, right? And along with this, we are also able to define this breed. So that is the way you can do it. Now let's try to create a object. Okay, called say for the dog class. What is the way I can create object? Let okay obj dog equal to new dog. Okay, you could see where we need to provide these two variable, right? Okay, name and the breed of the dog. So what is the name? I can give the dog called puppy of the dog name, and we can give the breed. What is the breed? We can give say bulldog. This is the bulldog type. Okay, and we are creating the constructor automatically, or this method will be invoked. This constructor will invoke and get the output. That's all. Let's run it now. So because the constructor is that, you no need to call the object. As and when you are creating the constructor with the new keyword, automatically your object will be created and constructor will be invoked. So let's run it. You could see the name of the animal is puppy. So here in this particular child class constructor, I did not define anything called puppy, but I have called the super keyword. Means we are trying to access it, right? This one, this constructor invoking, and this output is coming. Name of the animal is puppy, and now other one we are already getting it. Okay, we are getting it. Name breed of the dog is breed. What is that? Bulldog. It is coming. So this is the way, with the help of the super keyword, we can try to call the parent class constructor and parent class method. We'll give okay. We'll take a pause. Then we'll go to the next topics. Any doubt? Any questions? Anyone? Okay. Now we'll go to the next topics, which is called polymorphism. So polymorphism again another of the very key important pillar of the OOPS, right? Poly means many, morphism means form. So it's Greek word derived. So there are two things of the polymorphism. One is called compile time or static polymorphism, and one is called runtime or dynamic polymorphism. So static polymorphism. So suppose say what is the kind of compile type polymorphism? So you are a same person, right? You are taking a training. So you can be student for me. You are at home. Okay. So in case you are at home, so what you can be there? Just a minute. Okay, so we are discussing about the like TypeScript polymorphism. So poly means many, morphism means form, means many form. There are two type of polymorphism: static and dynamic. So static is nothing but the compile time. Whenever you are doing any kind of problem during compile time, saving the code, you can get to know. But runtime, whenever you are running it, that time only you can get to know. So what is the best example of the compile time polymorphism? Suppose you are a person, you are taking a training from me, you are a student for me, right? In case you are going to office, you are the employee for the your organization. In case you are going to bank, you are the customer for bank. In case you are staying at home, you can be like a husband for your wife. Similarly way you can be a son for your mother or father, like that. So one person is behaving differently, so that is the called compile time polymorphism. And runtime polymorphism is nothing but in case same method, same variable is residing in both the parent and the child class. Okay, so during child class accessing the same thing, like your parent class will override and child class you will take the present tense. So that is called runtime polymorphism. Suppose say I am myself, my name is Haradhan Pal, so my surname is Pal, and I have a daughter called Swarnika Pal, whose surname is also Pal. So you can have one variable called last name, both are Pal. Okay. But after 18 years, whenever she is adult, she can feel that, okay, Pal surname I'm not liking. Okay, I want to change it. Okay. So what she can do? She can have same variable, but she can have the different value called any other name, surname. So after that, in case she is creating the object and she is trying to access that like surname, so she will get her surname, not my surname, because both variables are same, but value is different. But your child class is taking the present tense of the highest priority or the order. So that is the way child class will override the parent class. It is called dynamic polymorphism or runtime. So polymorphism is one of the key pillar of OOP, which allows one object to embody multiple forms. Visualize the button in software depending on its type. For instance, a submit button or radio button. The actions resulting from pressing it varies. In case submit button, you need to click on the submit button automatically. It will depend. In case radio button, you need to select the radio button, all the option one by one, whatever you are feeling. So this dynamic encapsulates the spirit of polymorphism. There are two categories already told: static and dynamic polymorphism. So static occurs when the method to call is determined at the compile time, typically through method overloading. It is called static polymorphism or compile time polymorphism or method overloading. So having multiple methods with the same name but different parameter. Although TypeScript does not support traditional method overloading as in some other language, user can achieve similar functionality through function overloading here. Whereas dynamic polymorphism or runtime polymorphism is called method overriding, where a subclass provides specific implementation of a method defined in its superclass or interface. In TypeScript, this is commonly implemented using interface or the abstract class. So let's understand about the TypeScript runtime polymorphism. Okay, so let's try to create a class called calculator. Okay, here I want to do some operation with two number. Okay, but number can be say integer number or string or any other type, right? So what we can do here, we can try to create a method with two number. Okay, variable, let I colon number and comma j colon number. And definitely return type will be also number. Okay. Similarly, what we can do, we can try to have one more stuff called add I comma string. So same method, but we are changing the data type, and output will be also string. Only number and number will be giving a number output. Otherwise, any string you are doing, it will take the string only. Okay. And one more thing I am doing called any data type wherever it can take apart from this one. Add method. This is called overloading. Same thing, we are overloading with different one. I can be any data type or j can be any, and our return put also output should be any. Okay, that's fine. Now here we will define the logic. Okay, if type of I, we are giving strict operator, means data type and value equal to sign number. In case it is a number, ampersand and b j also number, right? Both are number only. So it will do the arithmetic operation. Okay, then what will do? It will return a plus b, mostly arithmetic operation. Sorry, I plus j. Here it will do arithmetic operation. Okay, if okay, what I can do, another if we can do same way, copy it. If it is the string and it is also string, so it will be also I plus j, but it will be doing string concatenation. Okay, else what we will do, return null. Just I want to make it null. That's all. It's fine. Okay, yeah. That is the way I want to do it. Now what we'll do, we'll create a variable for this particular class or object called constant, variable called calculator equal to new calculator. Okay, here equal to sign. Now what we'll do with this particular part, I'll just call it, okay, console.log variable dot add. Now what we can do, there are three same thing we have created. Either we can give integer, say 20, 30, that will be fine. So it will be arithmetic operations, both number, and if we give string, it will be string concatenation, say hello world. Okay, then we can try to do other stuff, right? One number, say one hello, and one say number or on any boolean value, right? See what is the way it will happen. So let's run it. Okay, you could see null is coming. Why? Okay, output is coming null. Here we need to give type of. My bad. Let's see whether it's working or not. Yeah, you could see coming, right? So what we did, okay, created a class calculator. We are trying to add this, right? Same method. It is called method overloading. And where first one we are trying to give number, return type is number. It is called arithmetic operation. We will do. And second one is string and string. So it will string concatenation, return type is string. But anything is giving any. Now we are giving the condition. In case both are number, it will be doing the arithmetic operation. I plus j arithmetic. Sum it just. In case string, it will just concatenate two string without any space. Other thing, other combination, it will return null. So here we are creating the object. We are first passing 2 and 3, so it will be go for arithmetic operation 50. And here hello and world. So string concatenation, hello plus world is concatenated. And here it is different. One is string, one is boolean. So it is giving null, any type, right? We can give number also, number boolean, number any other, big int also. Let's give it big int. Okay, one number and one big int. So it will be also null only. Why? Because it's big int, we did not define, right? You could see last two is coming as null. So this is the way we can try to go with the method overloading or compile time polymorphism or static polymorphism. Now we'll discuss about the dynamic polymorphism or runtime or method overriding. So let's implement this and then we'll take a pause and we'll go for any questions you are having. Okay, what we'll do, we'll try to create a class called abstract. Mostly it can be achieved through the abstraction only. Abstract class called shape, where we can have a method, right? Where we will not define the method or we can have it also. Okay, so let's see. Let's try to do the runtime polymorphism. Abstract method with the abstract keyword, abstract say area. I want to define and return type is number only. Now what we can do, we can try to have a another class, called say square. Okay, extend shape. Okay, where we can try to have some variable called private data type. Private say site is the variable and number. Okay, then we can create a constructor. Constructor we can create called site variable colon number, and we can try to first call the super keyword. My bad. First call the super keyword so that we can access the parent class. Then we'll be using this dot side equal to side. That's all. Okay. So it is error coming is square is declared but not used. That is there is no need to worry about this kind of error. Now what we'll do here, whatever area method we have created, right? This one abstract method we will try to define it. Okay, so area colon number, we'll redefine it. It will calculate the square area. My bad. Number will be in n lowercase. It will be colon. Okay, it will be returning this dot side multiplied by this dot side. That's all. Okay, so this is the way I'm trying to just create the shape class where I'm just defining a method but did not have any body. But in the child class where I'm extending, I'm trying to call this method, but where I want to define the body, I want to override in the child class. Now what we can do, we can create a object from the shape, from the square, object equal to new square, and where we can provide the like number only, right? Say 12 side, one side value. Now what we can do, we can try to use console.log and we can try to call this variable dot method, whatever we called. What is the method area? Now let's see what's happening here. So output will be 12 into 12, 144. See how easily we can do it. So we are having a class called shape. We are just defining that functions with the data type returning. Now we are creating one more class. We are extending this particular. main class, abstract class. Okay, and we are defining some variable whatever required and creating a constructor, and we are like creating a method here. So same method we are calling it from the parent class, we are defining the body here and creating it. Now same way, if we want to have one more class called, say instead of square we can have something called rectangle. Okay, say give it called rectangle. Okay, extending shape, so we can have variable name called width and height. Okay, width and height, two variable. Okay, here also you need to pass these two variable. Now super is fine, this dot width equal to width, and then this dot side height equal to height. Okay, now what will be returning? Here it will be returning this dot width multiplied by this dot height. So that is the formula for area of the rectangle. Now what I will do, instead of here whatever created, we'll call it rectangle. We can create a variable called rectangle variable, and we can call this particular class called rectangle wherever you created. And here you need to provide two variable. You could see error is coming. We need to provide two argument. One is height and one is width. So let's give it say 12 and another is called 7. Okay, now call it. So it will be 12 multiplied 7, 84. And first one is 12 multiplied by 12. You could see. Okay, sorry, my bad. I need to change the variable name here. Otherwise, it's calling the square only. So now you could see the output change accordingly. Okay, it's 84. So that is the way we can try to do the runtime polymorphism, where you can have a class, right? We can have a class defined abstract class. We can have a method abstract also, wherever no body, or this method we can try to just like override with the body actually in the child class or the subclass. Then we can just call it. So this is the way you can have the polymorphism or the runtime or the like dynamic polymorphism or method overriding implemented in the TypeScript world. Any doubt? Okay. Now next topics we will try to cover the abstraction. So in the abstraction there are three important parameters. One is called abstract class, one is called abstract method, and one is called interface. Okay. So abstraction is nothing but the hiding the implementation details. So already given the example, right? In case we want to just send the mail, receive the mail, nobody know how it is implemented. What is the logic is happening? Okay, but we can like send the mail or get the mail. In case somebody is sending some message, nobody knows it how it is happening, but we can send or receive the message. So means we are hiding the implementation detail. So TypeScript abstract class is a special type of class that serves as blueprint of other classes. User cannot instantiate an abstract class directly. Instead, user need to extend it to create concrete implementation. It is used as base class for inheritance and can contain mix of method with actual implementation, which is nothing but the concrete method. And method also can be there sometime where there is no body. So abstract class we need to always define with the abstract keyword. An abstract method can have both. Sorry, abstract class we need to define with the abstract keyword. An abstract class cannot be instantiated, means we cannot get the object or instance from the abstract class directly. An abstract class can have two methods. One is abstract method, means no body at all, and non-abstract or concrete method where we can have the body. And then we can try to extend it to other class where we can try to implement all the unimplemented method, means all the abstract method we can try to define the body, then you can call it. So abstract classes help enforce structure in object-oriented programming by defining common method and property for subclass. To define an abstract class, user need to use the abstract keyword before the class declaration. Any method inside an abstract class that lacks an implementation must be marked as an abstract. An abstract method is declared within an abstract class using the abstract keyword and does not have any body or implementation in the base class. And any non-abstract subclass that extends the abstract class must provide a concrete implementation for all abstract method, enforcing a specific structure or contract for derived class. Now let's try to understand this implementation. Okay, we'll define an abstract class here normally. So same way, whatever we have defined it like that. Okay, so called abstract keyword should be there before the class, and let's try to create some called animal. Okay, so what we can do, we can have some method called animal eat and return type is string. So it is a abstract. Okay, here you cannot give the body because abstract method will not allow you to give the body. Okay, but normal method it will allow. So in the one, okay, here if you want to give the body, it will throw you the error. Okay, so let's give it void also. Okay, now let's try to give some body here. You could see error message is coming. Why? You could see method it can have an implementation because it is marked abstract. So either you need to remove the abstract keyword or you cannot give the body. So what we will do, we'll just copy it and we'll paste it. We'll create a non-abstract method, normal one first. We can create a normal method. We can remove the abstract keyword and we can try to create a method called drink. So this is common, right? Every animal will be drinking and mostly it's drink water. So I can make it common, which is non-abstract method, and concrete method where I can give the body, so that whatever subclass we are creating, that subclass also having the parent common method, right? So I can give that every animal used to drink water. That is very common. Now we can try to give this abstract method also, where we can make it eat. So no body is allowed. An abstract class we cannot create the object or instance. Let's try to create object or instance. See what happening. Okay, let obj animal equal to new animal. So it will throw you the error. You cannot instantiate or cannot create the object of the abstract class. Only normal class you can create the object. Okay. So what we'll do, we'll try to create a class called say lion. Okay, and it will extend the abstract class. Then what we'll do, we'll try to implement the all the error is coming. You could see non-abstract class lion does not implement inherited abstract method animal, so we need to implement it. Okay, here this option is coming. Okay, so that is the way we need to implement it. So what is the method? Abstract method, right? This one. Now we can try to implement same way here. Only the unimplement, not sorry, whatever is abstract only those method we can implement. What is the method name? Called eat. Right, now I can give it called lion used to eat meat, because that is the way I can vary, because meat is it is a method common, but I did not given the body. Now from the animal I can create n number of class, but eating structure for the animal is varied. But so I just define the method only, but did not have any body. Now whenever I'm creating any class, I will try to give the body accordingly. Lion, tiger, I can give that they will eat meat. In case it's deer, right, goat, they will eat grass. In case it's elephant, they will eat fruits, vegetables, like that. In case you human being, like we can create a called man or human being class. It will be having anything, veg, non-veg item, all this kind of stuff. Now from this particular object, we can create an object. Okay, that will allow. So I can create something called object lion. It will allow, because you cannot instantiate the abstract class directly, Because as and when you are defining the abstract word before the class should be abstract in nature, and that abstract class cannot be instantiated, means a object cannot be created. And in the abstract class, you can have abstract method and non-abstract method or concrete method. Concrete method or non-abstract method means it can have the body. Abstract method means it can only the method name but no body. And then whenever you are creating a child class, where you can try to give the body based on your child class preference, and then you can call it. In case you are having n number of abstract method in the abstract class, so you need to implement all the unimplemented method in the child class, otherwise it will throw the error. Now let's okay, we did it. Now what is the object name? Lion dot, call it drink, so it is fine. Okay, then we can call that eat. So this is the way I can just use it. Now I can have n number of thing there, div 5, run it. You could see every animal used to drink the water, especially for the drink, which is coming from the non-abstract method created in the parent class. Now I am trying to define the method from the parent class in the child class, which was abstract in the parent class. So now it is coming, right? So in case you are creating another child class called say dr, which is extending the animal, now I can definitely call this parent class method called drink, which will be common for all my child class. But this abstract method I am calling eat. But now I can give the body accordingly. For the drs, I can give the body called dr will be using only used to eat grass or any kind of tree, right? So that is the it will behave varied. So this is the way we can try to deal with the abstract class and the method. Okay. Now one more examples. I will give it, I think already given. Okay. And now let's understand about the one more concept in the abstraction called interface. Okay. So here, firstly, we are trying to define any class called abstract. And in the abstract class, we can have non-abstract or abstract method. Non-abstract is nothing but the concrete. Abstract method is called abstract method with the abstract keyword. An abstract method cannot have any body, whereas non-abstract method can have the body. And as and when you are defining class as abstract, you cannot instantiate or create the object. Only you can extend it to the other class, and then from this child class you can create the object, and you can just change the implement the unimplement method in the child class, and you can try to access this method along with the common non-abstract method from the parent class. But interface, what is interface? So in TypeScript, interfaces defines the structure of object by specifying property type and method signature, ensuring consistent shapes and enhancing code clarity. An interface in TypeScript is a way to define the expected shape of an object. Unlike classes, interfaces do not generate JavaScript code. They exist purely for type checking during development. Interfaces are extendable and provide better tooling support for defining object types. User can create base interface and extend them to build complex type, prompting code reuse and consistency. So let's give a very good example of the interface. So say like we are using our bike, car, basically vehicles for transport. Say like in India, couple of companies there for the like vehicle, and in the vehicle there are four-wheeler, bus, truck, all this stuff. So whenever any company is coming to do some business in India, and India government is having some rules to be followed. So whenever they are creating the vehicles, primarily say think about the four-wheeler vehicle, personal usage, right? There are a lot of brands like Tata, Honda, okay, and Maruti. All this brand is there, but every brand they need to use some protocol which is government is following, so that every vehicle should have their called seat capacity, tires, engine capacity, right? Then driver seat, horn, all this stuff. So these are the area I can create a method or variables, and I can define in the interface. And using this interface, okay, whenever any card is manufacturing, they need to follow it or implement all these. Apart from that, they can add something in their own, but they need to follow it. Think about that card. So in other country, mostly like your driver seat in the left side, but India it's right side. So how this logic will work in India? So in case they are creating manufacturing some card with the same pattern with some US and other country, you cannot run it in India. So it will fail. So that is the way interface will let you know What are the key things you need to implement by default? Without implementation, you cannot go for the product in the market. And you can definitely add body accordingly, which does not care whatever you want to do it. So there is a functionality called horn. You can have 2 horn, 3 horn in your vehicle. Seat capacity. You can have 4-seater, 7-seater, 10-seater based on your personal vehicle also. Depend. But you need to just call this method and you can just give the body accordingly. Okay. And from the interface you can create the object directly. And apart from that, interface also help for the multiples. Okay, inheritance. So I'll show you. But whenever class to class, either abstract class or normal class, you see the extend keyword is there for the parent child mechanism. But for the interface to class, it will be implements keyword. Interface to interface is the extend keyword again. So class to class, extend keyword. Interface to interface, extend keyword again. But class to interface, it should be implements keyword. So let's define a interface, very basic interface. So I can interface something called interface with the name called interface called car. And this is the way I can create the variable. Okay, called say brand string, say model string, price string. Okay, so this is the way I can have the interface car. Now what is the way I can do it? This is interface, and I can try to create an object directly called constant. Okay, called car object, and I'll be using the car interface. And here I can give the value equal to sign. This is the syntax. I can create the object. Now what is the I can do it? Uh, Constant car is fine. Now let's try to give the value for these variables. So what is the brand? Say brand is say Hyundai. Okay. Say what is the model? So model is say i20. Okay. What is the price? Price we can give it number variable, which can be anything number. So I can give it. It will be comma. Okay, that's fine. I think so. Here it will be comma value. We can give it to comma. Okay, model is fine. I20. And what is the price? Say 8 lakh. That is perfectly fine. Now let's try to call it console.log. And what is the object car? Let's run it. Let's see what's happening here. Any error is giving or not? Okay, some error is coming here. Okay, model I20. Error invalid TypeScript syntax. Okay. Yeah. So we have given some dot. That is the only reason. Now you could see it should work. Okay. You could see it is giving you the object of the car. So you have defined interface, and from the interface, how we can easily define an object using the interface. We can give the value. We can call it. So this is the giving you the object, right? Brand Hyundai, model I20, price equal to 8 lakhs. Now let's try to implement in the class. So this is the way we can have the relationship between the interface to object. Okay, but let's go with some class level with the interface. Okay, so just I will copy code and explain it. So what we are doing, we are defining interface animal. We are giving a variable name called name. We are defining a bot method. Make sound is void method. Okay. Here in the interface, what you need to do? You no need to define the abstract keyword for the method, but still that method will be default abstract in nature. So that is the benefit of the interface. In the abstract class, you can make abstract method non-abstract method. In case you want to use the abstract method, you need to use the abstract keyword. But for interface, whatever method you are calling without the abstract keyword, still it will be 100% abstract only. So no need to define the abstract keyword, but still it will be abstract method. That is the reason you cannot give the body. Now, in the interface, what we can do is creating a class cat, and we are implementing. So I already told, right, class to interface will be implement keyword, and here we are defining again variable and constructor, and now we are trying to give the body on the method which are implementing it, where you're giving some body. Now what we are doing, we are trying to create an object for the cat class. We are calling it. We are creating another object, passing the variable, and we are calling it. That's all. So this is the way you can have the interface and the class relationship. Again explaining. So we are creating interface animal where we are giving a variable called a name string type. We are creating a method called make sound where just no body. Though you are not using the abstract keyword, but still whatever method you are creating inside the interface, it will be 100% abstract in nature by default. So no need to use the abstract keyword at all. So what is the abstract method? It cannot have any body. We can implement in the other class. Here in the other class, wherever this interface is getting implemented, we are just implementing the body and implementing the unimplemented method as well. Now let's try to create one more method here. Okay, called animal called eat. Okay, you could see we have did it, but in the child class error message is coming. Why? Because you have created a method which is not implemented now in the child class. That means whatever interfaces you'll be creating, all the unimplemented method, you need to implement it in the class wherever you are implementing this particular interface. Now what I can do, I can try to have it same way. Okay, called, what is the method name I have written? It. Okay, cat, the name, eat milk. What is the problem? Okay, let me cut it first. Okay, here we need to give it. Yeah, inside this one, we need to give it. Yes, that will be fine. Now, what we can do? You can just call it here also leocat dot eat and leocat also here, whatever other was that dot eat. So, as and when you are creating a like non, you could see now. Okay, cat Leo makes sound mew, cat Leo eat milk, cat Luna makes sound mew, can like cat Luna eat milk. So you can have n number of abstract method like defined in the interface. But in case you are creating any class where you are implementing the interface, you need to implement all the unimplemented method by default. And in this class, you can have another method also by your own choice. That is fine. But you need to implement all the unimplemented method. An interface, whenever you are having some method, though you are not using the abstract keyword, but still all the method will be abstract in nature and you cannot have the body. And whenever you are trying to implement in the class, you need to give the body accordingly and you can change the body accordingly. So this is the benefit. Suppose you are creating a class, right, called car, and now you can already change, right? Car is can be having tire, seat, and you can change it based on your car type, whether it's a like personal car or commercial car or like 10-seater car, 7-seater car or 5-seater car. Also, it will change it accordingly. Now let's go for one more example for the interface where I will try to see the multiple interface, like multiple. So it is not possible through the class concept, but it is possible through the interface. So you could see we have created an interface called engine, where we can have only the horsepower of the engine number. We can have an interface called wheels. We can have the give the count of the wheel. We can have an interface called speed. We can have the speed limit number. Now we are creating a interface another called car, where we are trying to have multiple, right? You could see comma. This is the way multiple interface concept you can establish. One child, multiple parent, which was not possible through the class concept because of the diamond problem. But here it is possible. Now, what we are doing in this car, we are trying to create object, and whatever way is there, all the variable are passing it, and there we are calling it. That is the way we can establish the multiple inheritance through the interface. You could see it is creating the object. So we are creating multiple interface, and new interface we are creating where we are extending other all interface together. So this is the car is a child interface, and here multiple parent called engine, wheels, and speed. So interface to interface again extend keyword, class to class in extend keyword, but class to interface it will be implement keyword. So this is the way you can have this uh, multi pill inheritance concept established using the interface. Now one more example we'll see about the interface inheritance. Okay, one parent interface and one child interface only instead of multiple. So we are creating a car interface, we're having horsepower, wheel count, speed limit, and we're having a luxury car interface which is extending the car. Means whenever you are creating normal class car, right? Normal car might not be having music system. Normal car might not be having reverse camera, might not be having AC, all this stuff might be there. Normal ordinary car. So this is the way I have created a interface called car, or you can give it normal car. But other interface I'm giving luxury car, which is having the luxury car properties. Apart from that, it will having all the car properties as well. So then means whenever you are using normal car, you need to use all the variable from the normal car. But luxury car, not only car, apart from that extra properties from the luxury car also get it. So this is the parent interface, this is the child interface. Now from the child interface, we are trying to create it, right? So or the parent whatever way we want to do it. So then you can create the object and then you can call it. So that is the you can give the value. And now let's save it and run it. You could see object is coming. So this is the way you can have this parent child mechanism also called single level inheritance is possible through the interface, and multiple inheritance I also showcase in the other example. So I'll take a pause. Any questions? These topics are a little bit not so much pretty straightforward. Just go through the recording once and go through the document and practice it. After that, slowly you'll get the confidence. Very key concept, very key important topics is the like OOPS concept. Okay, it looks very straightforward but not very much easy. This is the heart of the any programming language, right? The OOPS. Yeah, right. Okay, we'll go to the last interface concept, sorry, last OOPS concept, which is nothing but the encapsulation. Okay, so whenever we talked about the abstraction, it is nothing but the hiding the implementation details. Whereas encapsulation is nothing but the hiding the data, or also it is called binding data and method, variable and method together inside the class. Just like capsule, multiple ingredient we are mixing it, and multiple stuff we can do it, right? But we will not sure which ingredient, which module is from which thing. We are not able to isolate it. So similarly, encapsulation in TypeScript involves bundling data or properties and the method that operate on the data into a single unit or class and controlling access to them. This practice protects the internal state of an object from unauthorized external access, thereby ensuring data integrity and making code more maintainable. In TypeScript, encapsulation is enhanced with type annotations, providing additional check at compile time to ensure error-free operation. So, a simple example. Say you are having a bank account, right? In case you are not encapsulating it, anybody can access your bank information and they can get to know whether how many what how much amount you are having in your account, and definitely it might be trouble for you. Do not want to disclose all your amount to anyone, even your family member also. You want to make it confidential. But in case you are calling some deposit or withdrawing, you can get some message, you can verify it, right? So this is the way I want to do it. So TypeScript helping with the encapsulation features, that only data hiding. So data I want to hide it. So TypeScript enhance this with the type of annotation for class property and method parameter. TypeScript uses access modifier, three access modifier: public, private, protected, and getter and setter method to achieve encapsulation. Okay, let's go through this code to give one more complete example. Then you can understand the encapsulation. Okay, so what we are doing? We are creating a bank account class. Now what we are doing? We need to create a private variable for the encapsulation. The variable should be private, and there will be getter and setter. We will set the value and we will get the value. So we are not able to directly access the variable directly. No. With the setter value, we will set the value, and with the getter method, we will get the value. Okay. So we are getting a private variable called initial balance. Okay. Now we are creating a constructor. If initial balance greater than 0, it will just show you the initial balance. Else, it will be throwing the error that initial balance cannot be negative. So this is the trap I am creating the constructor. I'm creating a class called bank account. I'm defining a private variable called initial balance, and I'm creating a constructor where giving some condition. In case only initial balance is greater than 0, then you will get the value, and then otherwise it will throwing the error called initial balance cannot be negative. Then what is the method I'm calling called deposit method? You can create one method called withdraw method also. If amount greater than 0, then your initial balance will be added to this amount. I think this part I already covered in the last session. Then it will print out the value called initial balance, new balance, with this initial balance plus amount. Otherwise, it will be giving you the error called deposit amount must be positive. Okay. Now we are creating a method called get the balance. So here we are setting it, and then we are getting it. So returning this initial balance. Now what we are doing? We are creating the object called bank account. We are trying to deposit, and then we are getting the balance. Now let's do it, run it. So this is the way I can do it. Private variable, getter and setter. You could see initial balance was say $7,000. Sorry, initial was 5,000, and now we have added 2,000, so balance is 7,000. But can we able to access the variable directly? Then there is no point of adding this method. All this getter and setter. No, it will not allow. You could see whenever you are trying to access the variable, it is showing the error. Property initial balance is private only, and only accessible within the class bank account, not outside this class. So this is the way I can have the private variable, and private variable can be used using the getter and setter method. Setter is setting the value, and getter is getting the value from this way. So I do not worry about this variable directly. Instead of that, through other way, I am trying to set the value and get the value. This is called abstraction or data hiding. So I cannot access the data private directly. Instead of that, whenever I am depositing or withdrawing the money, I can get the thing right here. That is the through message or through bank statement or through email, all this stuff I can get it. So this is the way I can try to encapsulate. This is the one area, okay, of encapsulation. Now encapsulation also can be achieved with the access modifier. What is access modifier? Access modifier in TypeScript control the visibility of and accessibility of the class member. Or class member is nothing, it can be properties and method. Properties is nothing but the variable, okay, which will help to enforce encapsulation. So TypeScript control the access logically during compilation time, not at runtime. So only compilation time it will get that logical validation. So there are three main visibility of the access modifier in TypeScript: public, private, and protected. Public is nothing but the member are accessible from anywhere inside the class, including inside the class, outside the class, and derive or child class also. If user do not provide any access modifier for the property method, they will by default take the public modifier. By default, they will take as a public. In case you are not defining something, it will be public only. That is the reason whenever we define couple of method right here, we did not define anything. Okay, like variable label, we did not define anything. That means it's public by default. Okay, in case you are creating some method, right? You could see couple of method you have created, make sound. It's public. So it means accessible anywhere inside the class, outside the class, or subclass. Means is the whole project is accessible. That is the private, public variable or the method, whatever. Now private. So members are only accessible within the same class where they define only within the class level. Outside the class, even inside the derived class or the child class also you cannot access it. So they cannot be accessed from the outside the class, even by the derived the class. So private only accessible within the class, not outside the class, not in the derived class or the child class. Public is accessible anywhere. Derived class, inside the class, outside the class. The last one is protected. So protected definitely accessible within the class. Apart from that, protected also can be achieved in the subclass or derived class. So this is the main difference. Public anywhere, outside the class, inside the class, subclass. Private only inside the class, no outside the class, no subclass. But protected can be accessible inside the class and the subclass, but not outside the class. So member protected are accessible within the class. They are defined in and in any subclass derived from it. They are not accessible from outside the class hierarchy by an instance. The TypeScript compiler will issue an error if the user attempt to access the protected properties or method from anywhere else. Now let's see the implementation. So let's define a very important stuff. Okay, called class. Okay, called employee. Okay, okay, I can create a variable called public access modifier name. In case you are not giving to it, she'll be calling as a public. Okay, called name string. I can create a constructor. So this dot name equal to name. Okay, then I can create a method called again public. Okay, uh, display employee name. Return type will be void. Okay, just I can try to print out console.log name. Okay, now what we can do, we can try to create an object. Object like called a constant obj object equal to new employee, and here I can give that employee name. So my name is Haradan Pal. Okay, now what we can do, we can try to just print it out. Okay, console.log called object.name. Okay, apart from that, I can do it, call the method called display company name also. So there will be no error because this is the public. Both your variable is public, your method is also public. So accessible outside the class any point of time. Okay, you could see it is coming as both the method, right? Okay, variable also you can do it, or method name also you can do it. Okay, this method you can do it more better. We can use the literal here so that you can understand the difference. String literals. Okay, here what we can do, call employee name colon dollar sign. Okay, this bracket, and here I can end with this bracket and end with the literals. That will be fine. Now let's run it so you could see. Yeah, okay. The first one is calling the variable called name. Second one is calling the method display name, right? Employee name rather than Pal. So both are public, so I can try to access it inside the class, outside the class, and even subclass also I can do it. Now let's make it private, the variable level. First, make it private and see what's happening. Okay. So private here, no problem. But whenever you are trying to access it, the variable, you could see error is coming. So property name is private only and accessible within the class employee. No outside the thing, you cannot do it. Now let's make method the private method, private also. Okay. Again, you could see the error message is coming here. You cannot do it private, right? Okay, private, only accessible within the class employee. Similarly, if you want to make it protected, okay, here method also protected. You can just try to access it, but you need to just create a subclass. That's all, you can do it. Okay, let's create a subclass here. What we can do? Mm, let's try to create a subclass called class. Okay, say HR employee. Okay, or a admin. From the employee, I can have some department called admin employee. Okay, here extend call employee. Okay, sorry, my bad. Extend employee. Then what I can do? I can just create a method called display details. Employee name here. Okay, called display admin employee name. Employee name void. Okay, same way I think it should be fine. Okay, we call admin employee name. Okay, now what we can do? We can try to create an object for this admin. Okay, object name called obj admin. Then you could see with this object I can try to call it. I don't think it will be problem. And new method is called display, yeah, admin employee. Now you can run it, right? So this is the way we can try to call it. You could see whenever it's protected, right, it is accessible through the child class. But whenever private, we cannot do it through child class. Only it is accessible inside the class. No outside class, no child class. Public variable or the method can be accessible inside the class, outside the class, or child class. You are making the private, there will be no problem at all. Sorry, public. Okay, both are fine. Public is fine. So subclass is fine. No worry, right? You can do it subclass. But make it private again. So subclass also will not allow. Okay, let's do it private. Okay, subclass also not allow. See here, come here, error message is there. Okay, you could see immediately error message is coming. So you cannot access it because you have already make it private. So subclass also is not possible. So this is the way. These are the three access modifier really help us. Okay, for dealing the encapsulation along with the getter and setter. So public, private, and protected. So access modifier in TypeScript control the visibility and accessibility of class member. Class member is nothing but the property method. Property is nothing but the variable, and method is nothing but the reusable component or functions. Now we'll discuss about the TypeScript read-only properties. Then we'll just cover one more topics. So after covering these topics, I will take a pause for any questions. Okay. So read-only property is nothing but where you can only read the data, you cannot update any kind of data. So sometimes think about the global configuration where you having some common URL, username, password. You should not change it, na? In case you are having some setting, right? Your zoom window, your color, your font, all these things you want to don't want to change it by anyone. So you can make it fixed. Okay. Suppose your surname, you want to make it constant so that no, you do not want to change it for a family member. You can make it fixed as a read only. So the read only utility type in TypeScript create an immutable version of an object type. It prevents properties from being reassigned after initialization, helping catch bug early and making user code more predictable, especially in classes like configuration object, constant mapping, and function parameter that should not be modified, or okay, the value should not be modified. User can apply it to object, array, record, and event classes. User can define an abstract class with read-only property in TypeScript. The read-only modifier prevent reassignment of property outside of it declaration or the class constructor, while the abstract modifier ensures the class not be instantiated directly and is meant for inheritance. Let's see the implementation. Okay. So in the array, you already see we can define the array and we can call some method called push, pop, shift, unshift, all this stuff, right? Let's create a called constant. Okay, create something called variable called num, and let's give it called numbered array. This is the array symbol, and where we can give the value called say 1, comma 2, comma 3, comma 4, comma 5. Okay, this is fine. Now what we can do, we can try to print out log num. That's fine. So it will not be a problem at all. We can print it out. Okay. Now what we can do, we can, after adding the value, we can try to do it called push method. We can call it push pop all this part na. Okay. Let's add something push called 6. So it will add the element at the end. Okay. You could see now output is coming. Okay. We can try to write pop. So it will try to just remove the element from the last. Okay, if you were just using shift, see what's happening here. Okay, it is removing the first element, right? Shift, unshift will add in the first element, push will add the element at the last, like shift will be removing the first element, and yeah, pop will be removing the element from the last. That is the stuff. Now I want to make this variable as constant or read only, so that I do not want to do any kind of update operation. I can just only view it. So what I can do, I can make it after the uh, variable type called read only. That's all. Okay. You could see middle error is coming here because property push does not exist on type read only. You cannot modify it. You cannot do the update. All this part. So it cannot be done. It will be throwing you the error. Only you can view the data. Right? It will be error. Okay. You could see error is coming. Is fine. Commenting out. And next line also error is there. Why? You could see does not read only number, right? This read only number, so you cannot do this kind of operation. Now it's fine. Now you can run it. Okay. So you can, whenever you are defining something as read only, you cannot change the value or you cannot reassign it. Okay. So read only is nothing but to creating an immutable version of an object type. It prevents properties from being reassigned after initializations. Okay. Without read only, you can do normal way. Okay, so another examples just I have given. So for the read only, suppose in case you want to do a couple of important stuff, read only part, right? This is the way we can do it. Okay, so we have defined some type called settings where we given two variable called theme and font size. We are trying to give the read only, okay, dark and font size. After that, we are reassigning the value. It is throwing the error. But if you just change read only, it will not be a problem at all. Just cut it. Okay, it will be, you can allow it, right? Themes might be possible to add it, but whenever you are just using read only, so you cannot define it, redefine it. Okay, it will be throwing the error. So this is the way read only helps user, right? Not to change any value or to make it static or to make it immutable. This is the concept of the read only. So sometimes you do not want to change it, so those you can make it read only, so you can view the value but you cannot redefine or redeclare it. or it will help you to immutable to get an immutable version of this type. Okay, any questions? Okay, then we'll go to the last part of the TypeScript today. Okay, which is yeah. Uh, Here also one example the gear, like we are defining interface, like car, model year, and we are giving read only fuel only. So we can try to define the value once. After that, we can get it, but the fuel part we cannot redefine it. It will throw in the error. Why? Because we have make it read only. Okay, model and year will change, but fuel capacity, right? The engine capacity will be mostly same for any of the brand. Like it's for the 3 liter, 45 liter, 50 liter mostly. So we are making it read only, so we can view it only. We cannot change it. We can use it, but model and year will be changed every year, every model. Model might be constant also sometime, but year will be changed every year. Production will be coming like that. So this is the another way example of the read-only properties. Now we'll discuss about the error handling. Okay, what is error? So sometime in couple of the script, right, there might be error. So what is the problem of the error? So main problem is that in case there is a error, your script will stop the execution on that line, and remaining line of code will not be executed. That's the problem. Okay, so you need to handle the error so that you can get the error, but all your code should be executed uninterruptedly, and you can have n number of error from your execution. Suppose in case you are having 1000 line and your error is coming at the line number 2, but in case you did not handle the error, so from the line number 2 the code execution will stop and remaining line will not be get executed. So you know that error might be coming, but your objective is to execute all the line of code at least once, and you can get 20, 30 different error also at the same time. So this is the way error handling is really important in any of the programming language. Okay, like Java, C Sharp, JavaScript, TypeScript, whatever programming language you are using. Mostly common thing, try, catch, and finally block are used to handle the error. Okay, so functional programming language such as TypeScript and JavaScript provides a way to handle error using the try catch block. The try block catches the error and the catch block handle the error. Try block will only try to catch the error, but you require the catch block so that error can be handled. The try block can contain the code with error. If the error occurs, it will throw the error and stop executing the code from that line where it occurred. And as the name suggests, the catch block is used to catch and handle the error. User can write the code to handle the error in the catch block according to different error category. There can be multiple catch blocks for a single try block as well. User can create different catch block to handle different kind of error such as syntax and reference error. Then finally block is also there, which in you can use it in continuation with the try catch block. But what is the main difference between try catch and finally block? So try catch block will try to handle the error in case error is coming. In case there is no error, your try catch block will be completely ignored. But your finally block will be always executed irrespective of try catch block, your error is coming or not. So you can surround the try catch block with finally block. So especially whenever you are working with some file, whether error is coming or not, you want to close the file. We want to have this kind of step common. Whether error is coming or not, whether your thing is working fine or not, but you want to open or close the file. So those kind of stuff you can have in the finally block. So irrespective of the error is coming or not, this block will be always executed and you can get the desired result outcome. So the finally block contains the code that is always necessary to execute before program termination. For example, database connection closing or file closing, which user had opened in the try block before the error occurred. So finally block will be always executed. This is syntax: try, code with error, catch, handle the error, finally execute the code before program termination as a mandatory, no optional. And try catch block can be ignored in case there is no error. Now let's see one of the implementation of the try catch block. So what we will do, we will try to create a very important, very simple function with the function keyword, okay, called division. Okay, here we can have two number called m colon number and n colon number. Okay, I can have some body. Okay, if n equal to 0, Okay, then it will try to throw some error. So throw keyword can be used to define custom error. Throw keyword along with try catch and finally. So new error, and here I can try to define called, okay, division by 0 arithmetic error. That is the arithmetic problem mostly, and otherwise it will return, okay, return m divided by n. That's all. Okay. Now what we can do, this is the method I have written. Now I will try to have some code. Okay, console.log. Okay, here I can give something called code before any error occurred. Okay, one more line, code after any error occurred. So here just we have created the method only, we did not call anywhere. So in case you are writing, you could see both the line is coming wherever your console.log is there. Now here in the middle, let's try to call this method. Okay, so what is the method name? Called division, and what we are dividing? M by n. Okay, so return type will be your variable constant. I can have stored in some result variable equal to division is the method name, and where I can try to give something called 20 divided by 0. Okay, then what I can do, 20 comma 0, sorry, my bad, comma 0, two variable I am passing it, which will be returning m divided by n. In case it is equal to 0 any value, it will throw you the error. Okay, then we are trying to print it out also, console.log, the print the value of the result. Okay, now see, so here the problem will be coming this line. So because of the problem, next line of code will not be executed. That is the problem. Here not about the error. It's a error, and thing is that error is definitely there, but remaining line of code is not getting executed because of this error. You could see the output. It is coming here, right? This came, okay. Code before any error, this executed. After that error came, okay. Here the error is coming, right? So division by 0 arithmetic error is coming. After that, next line of code is not executed. Your execution is halting there, here only, and remaining line of code is not being executed. So what we can do, we can handle it with the try catch and finally block. So here we can use try, so it will handle the error. Okay, what is try? Nothing but the code with the error where the error is coming. Now we can end it there, it will end. Okay, now we can go with catch, it will be getting the error. Okay, now what we can do, we can catch it, the error part. Okay, here I can try to do console.log. Okay, that error occurred. Okay, and we can try to get the error called error as error. This is the syntax you need to call it, and here you need to pass the dot message, so that message will be called, okay, from the error. Then we can have the finally block also surrounded. So finally block will be always executed irrespective of the error is coming or not. So console.log, I can give it called code for finally block is being always executed. Now let's run the code and let's see. Error will be coming, but it will be handled, and remaining line of code also will be executed. Okay, you could see code before error coming, right? After that, whatever division by arithmetic is coming, and then finally block executing, and code after error is also coming. That is the beauty of this try catch block and finally block. So try catch, try block will first your code with the error wherever error is coming. It will just get the error, and catch block will handle the error, and finally block will execute the code of the program before termination, irrespective of the error is coming or not. Okay, so this is the way you can deal with the try catch and finally block. Now let's see error is not coming. Say we are trying to divide 20 divided by 2, so what will be the output? 10. So error is not coming, so your try catch block will be ignored, but finally block will be always executed irrespective of error is coming or not, and your remaining line of code also will be executed after the thing, right? You could see here code before error is coming, then output is coming. 10 divided by 2 is nothing but 10. 20 divided by 2, there is no error, final block is executing, and the remaining line is also executing. So your try catch block will be completely ignored in case there is no error, but finally block will be always executed irrespective of the error is coming or not. So I'll give you a couple of more example. Okay, this is the one more example I've tried to create. I've created a function called validate password where I'm passing the parameter called password. Now I'm giving a try block. Okay, if my password length less than 12, I'm showing a new error, password too short. Okay, otherwise is good. Okay, then we are in that catch block, we are trying to handle that error message. Okay, then what we are doing here, we are trying to give one valid password and one is less than 12 digit password. Okay, then let's run it, let's see what's happening here. Okay, so let's call it. Yeah, you could see whenever we are giving the good password, it is not coming with the try catch block. So it is completely fine. No output is properly coming. Whenever you are giving less thing, you could see validation failed, password too short, because it is going from this error through. So this is the way you can handle the error so that remaining line of code will not be a problem. One more example I have just jotted down, the last one. Okay. Say what we am doing here. Okay, we are creating a function called error handling. We are defining two variable, number one and number length one b and b. We are matching both the data types strict equal operator, strict equality. In case both number one and number two is having the same data type along with same value, we can provide it the number are same. Otherwise, you will throw the error called provided number are not same. Then we are having one more functions handling the error, right? We are calling it in the functions. Okay, like 7 and 9 value, and now in case any error we are trying to catch it, error dot message, then you are calling this function, like so. Here it is different, so see what's happening here. Okay, you could see an error occurred, provided number are not same. This text is from the finally block in respect to the try catch block. Now in case you are giving it like 7 and 7, so your only final block will be executed, your error will not be there. Okay, your output is coming, the provided number is not same, which is a normal thing, not any kind of exception, right? You could see this output, but here not same, it is coming from the error or exceptions. So this is the way you can try to handle the error in the TypeScript. We can do it with the try catch and finally block. So let's try to recapture one more time before wrapping it up. After that, in case you are having any questions, we'll discuss it. So today we first understood about the OOPS concept. OOPS is nothing but the object oriented programming structure. Mostly all the modern like technologies, programming language like Java, C Sharp, Python, JavaScript, TypeScript, C++ also follow the OOPS concept. There are four key pillar of the OOPS: inheritance, polymorphism, abstraction, encapsulation. Along with that, class, object, and construct will be definitely there as part of the OOPS. So inheritance is nothing but the parent-child relationships, where like your child try to acquire all the properties or the variable or the method from the parent. Okay, it is called base class and the child class or subclass, or parent class or base class or child class subclass. Inheritance can be single level, one parent one child, multi-level, like chain of inheritance, grandparent parent child, hierarchical inheritance, one parent multiple child. Multiple inheritance is possible through the interface but not possible to the class, to the diamond problem. And hybrid inheritance TypeScript does not support, where we are trying to inherit using multiple uh, Like hybrid inheritance is nothing but combination of two or more types of inheritance which TypeScript does not support. So TypeScript support mostly single, multi-level, and hierarchical through the class, and multiple also through the interface concept. Then super keyword also can be used to call the constructor of a parent class or to call the method of the parent class. This is the super keyword can be used. And TypeScript polymorphism is nothing but the many forms. There are two types of polymorphism: static polymorphism or compile time polymorphism. Okay, and dynamic polymorphism or runtime polymorphism. Static polymorphism is known as method overloading. Okay, so TypeScript does not support traditional method overloading, but it supports the functions overloading where we can have the same function with different data types. And runtime polymorphism is nothing but the method overriding where a subclass provides a specific implementation of a method, define its superclass or interface. In TypeScript, this is commonly implemented using interface of the abstract class. Okay, abstract class we can create it, and abstract class and interface we cannot instantiate it or create the object. Abstract class, right, we can extend to the other class. Abstract class can have both abstract and non-abstract method. Non-abstract method is or concrete method can have a body, whereas abstract class cannot have a body. Abstract class could be created with the abstract keyword, and then you can extend it to other class. But whenever extending, we need to make sure that all the unimplemented method we are implementing to the normal class. An interface is nothing but in 100% abstract in nature. In the interface, though you are not defining the word called abstracts, okay, but all the method whatever you are defining, like all will be 100% abstract in nature. So interface you can try to extend in the other interface using extend keyword. An interface you can extend multiple interface, that is the multiple inheritance is also possible. And to the class you need to use the implement keyword to the using the class and interface. And whenever you are implementing to a class, all the unimplemented method from the interface to be implemented in the class. Encapsulation is nothing but the data hiding, whereas abstraction is nothing but the hiding the implementation details. So data hidings can be achieved through the private variables and getter and setter method. Apart from that, encapsulation also there are three type of access modifier. Also, you can use it public, private, and protected. So public is accessible anywhere inside the class, outside the class, or subclass. Private is only accessible inside the class, but not outside the class or subclass. Whereas protected is accessible inside the class or subclass, but not outside the class. Read-only properties in case we want to make something fixed or we want to make something immutable, so we can make it as a read-only. So once we define read-only, we cannot reassign the value after initialization. That is the way read-only also used. The last one is error handling. So in case there is error is coming, in case we are not handling the error, so it will stop the execution at that line, and the remaining line of code will never be executed. That is the reason we need to handle the error properly so that remaining line of code can be executed. So whenever any error is coming, right, we can handle the error with the help of the try, catch, and finally block. So try block will first find the error, okay, or we can have the code wherever error is there, and catch block will handle the error, and finally block will be always executed irrespective of the error is coming or not. Okay, so in case your error is not coming, your try catch will be always ignored, and in case your finally block there, it will be always executed. So finally block primarily used to close any kind of database connection or file which is already open. So in case your error is coming or not, you can close the file or database at the end before terminating the program. So this is the way TypeScript allow you to handle the error. Okay, so that's all from today's session, guys. Thank you. We'll catch up in the next session.